everyone. You are welcome to physics class online. Please subscribe to this channel, like the video and comment, and at the same time you can turn on the notification bell. Alright, today we'll be looking at another topic, which is techniques and measurement. In previous classes we look into dimension, and we look into multiples and submultiples of unit, and on that class we look at how we convert from the multiples of SI unit to the SI unit. At the same time we convert from the submultiples of SI unit to the SI unit. We said multiples of SI units are the larger values of SI unit, while the submultiples, they are the smaller values of the SI unit. So today we'll be looking at measurement and instrument. Now let's look at what measurement is. Measurement is an important aspect of physics or other science. Why? Because no fact in science is accepted, no law is established unless it can be exactly measured and quantified. We've established this statement in our previous classes. Now, as physics is based on exact measurements, so every such measurement requires two things. And the first is a number or quantity, while secondly a unit. For examples, in previous classes we introduced ourselves to physical quantities. I said if I write 20, 20 is not a physical quantity because we don't know 20 what. Is it 20 meter? Is it 20 seconds? Is it 20 kilometer? And so on and so forth. Until there is a unit of measurement, then no value is accepted. So that is why in physics, the exact measurement unit of a value determines the value, whether it's a physical quantities or not a physical quantities. So that's what we are talking about here. Examples: when we see 20 and we see meter, then the meter suggests that the physical quantities in context is length, where 20 represent the quantity and meter represents the unit. Now let's look at examples of those measurement instruments. So we have four categories of measurement. Then we have measurement of length, we have measurement of time, we have measurement of mass and weight, and then we have measurement of volume. So let's start with the first one. The first one is we'll be looking at the measurement of length. Now, a device for measuring length, we have about 3 or 4 categories of instrument that we use to measure length. We have the meter rule. A meter rule is often used to measure distance of few centimeters to some meter. For example, the dimension of a table or a room, we can use a meter rule to take that. But when longer distances are involved, we use tape rule, can be used to measure. And the smallest graduation of a meter rule is 0.1 centimeter or 1 millimeter. If you look at a meter rule, or pick any meter rule, you discover that the smallest graduation there is 1 centimeter, and the 1 centimeter is broken down into smallest unit, which is 0.1 centimeter. There are 10 lines that makes 1 centimeter. So each lines represent 0.1 centimeter. That's what we are talking about. Then we have another device that we use in measurement that we call caliper. Calipers are used to measure distance on solid objects where an ordinary meter rule cannot be applied directly. For instance, if we want to look at the diameter of a ball, we cannot use a meter rule to measure the diameter of a ball because ball is round, so we cannot use it to measure it perfectly. So we use another device to measure such diameter, and we use the caliper. Now, caliper, they are made of hinged steel jaw which are closed until they touch the desired parts of the object being measured. The distance between the jaw is then used on the graduated scale, such as the meter rule. By the time we close it, I'll be showing you a video very shortly that you see how we use the calipers in measurement. Just continue with this video, and before we finish this class, we'll see more on how to use the caliper in taking measurement. Then we have the vernier calipers. Then we have the vernier caliper. Well, vernier calipers, these can measure lengths more accurately than the meter rule, and to measure small lengths to the nearest 0.1 millimeter. For examples, if you want to measure the thickness of a meter rule, we want to measure the internal diameter or external diameter of a tube, or we want to look at the diameter of a rod, we use vernier caliper. So this instrument we are talking about has two sets of jaws and two scales. We have the main and the vernier scale. This one will be shown uh, in this slide. As we are looking at the diagram here, you see we have inside jaw. The inside jaw is to measure the inner diameter of the shape, while the outside jaw, the inside jaw is to measure the inner diameter of a shape, while the outside jaw is to measure the outside diameter of a shape. This is a diagrammatic illustration of a vernier caliper. But as we proceed in this class, we'll look into how we can use this vernier caliper to take measurements. Now we have another instrument, which is the micrometer screw gauge. This instrument measures even smaller lengths. A vernier caliper measures smaller lengths than what a meter rule will measure, while a micrometer screw gauge will also measure a smaller length than what a vernier caliper will measure. So the instrument measures even smaller lengths than the vernier caliper, as I said here. So this is an example of the micrometer screw gauge. Now, a micrometer screw gauge has higher reading accuracy and can read up to 0.01 millimeter. Remember, I said in the previous statement that if you look at the vernier caliper can only measure to 0.1 millimeter, as you see in this chart, while a meter rule can only measure to 0.1 centimeter or 1 millimeter. 1 millimeter. A vernier caliper will measure to 0.1 millimeter, while the micrometer screw gauge will measure to 0.01 millimeter. So it can be used to measure the thickness of a piece of paper, like the diameter of a small ball. You want to measure the diameter of a small ball or the thickness of a paper. You look at a paper, if I say you tear a sheet of paper now, you know how thick the sheet of paper is. So if you want to measure the thickness of a paper, then we use an instrument called the micrometer screw gauge. So this is a micrometer screw gauge. This is just a diagram of a micrometer screw gauge. You see the thimble scale, we have the ratchet, we have the main scale, you have the thimble scale, we have the spindle, we have the anvil, and so on, as we see in this chart. Now let's look at how to take measurements now using a vernier caliper and a micrometer screw gauge. So let's go to the class now, and I will display to you the vernier caliper and the micrometer screw gauge and explain how we use it to take measurements. All right.
To slide open the movable auxiliary scale or movable jaw, hold the vernier in one hand and use your thumb to roll the jaw's adjustment wheel in or out. The movable scale should slide easily. Some calipers have a locking mechanism to secure the auxiliary scale in place, so if it does not slide easily, check to make sure that the locking mechanism is not engaged. To measure the length of an object, simply slide open the caliper's auxiliary scale and place the object between the large jaws. Then firmly close the jaws on the object and make your reading. To measure the outer diameter of a round object, such as a cylinder or sphere, slide open the caliper's auxiliary scale and place the object between the large jaws. Note that when measuring the outer diameter of a cylinder, the jaws should be perpendicular to the cylinder's length. This ensures that an accurate reading of the diameter will be made. If the jaws are parallel to the cylinder's length, it is quite likely that an inaccurate reading will be made. Once the jaws are properly closed around the object, make your reading. To measure the inner diameter of a hollow cylinder, such as a pipe or length of tubing, slide open the caliper's auxiliary scale and place the small jaws within the cylinder's hollow opening. Then expand the jaws so they make good contact with the inner wall of the cylinder and make your reading. To measure the depth of a hole, Slide open the caliper's auxiliary scale and place the depth indicator into the hole. Adjust the auxiliary scale so that the length of the depth indicator is exactly that of the depth of the hole. Once the auxiliary scale is properly positioned, a reading may be made. Note that the length of the depth indicator is equal to the separation of the caliper's jaws. Most vernier calipers purchased in the United States give readings in both inches and centimeters. As always in physics, we will work with metric units. Like a meter stick, the vernier caliper is calibrated in centimeters with the minor or smallest divisions in millimeters. However, unlike a meter stick, the vernier caliper allows the fractional part of the smallest division to be accurately determined, not merely estimated. Using the vernier caliper to measure the length of an object is not as difficult as it may appear. The first line on the movable vernier scale is called the zero mark. To make a reading, note where the zero mark on the movable scale falls on the main scale. In this example, the zero mark falls between the 6th and 7th major divisions on the main scale, so we know the reading will be between 6 and 7 centimeters. If we study the caliper more closely, we see that the zero mark on the movable scale also falls between the 3rd and 4th minor divisions. Therefore, the reading will be between 6.3 and 6.4 centimeters. To accurately determine the fractional part of the smallest division, you must decide which line on the movable scale coincides with the mark on the main scale. Here you can see the second line on the movable scale matches a line on the main scale, so the fractional part of the smallest division is 0.02 centimeters. Therefore, the length is measured to be 6.32 centimeters. Try to determine the length of the aluminum block yourself. Here is the vernier reading as measured by one of our students. Pause the video now to determine for yourself the length of the block. If you determined that the length is 3.29 centimeters, then you were correct. If you recorded the length to be 3.28 or 3.30 centimeters, replay the video and closely observe that it is only the 9th line of the auxiliary scale which matches exactly with the division on the main scale. Therefore, the reading is 3.29 centimeters. Now try to determine the radius of this aluminum sphere. Pause the video so you can accurately read the vernier. If you determined that the radius is 1.12 centimeters, then you were correct. If you found the radius to be 2.24 centimeters, recall that the vernier measured the sphere's diameter, not its radius.
Okay, how to take reading? So the reading of the micrometer is equal to the readings of the main scale. This is the main scale, plus the readings of the thimble scale. This is the thimble scale. This is the main scale. This is the thimble scale. So the reading is equal to the main scale plus the thimble scale. For example, this one. The readings of the main scale, each one is 1 mm. 0, 1, 2, 3, 4, 5, 5 mm. But then here, in the middle of these two, we have another scale here, right? Okay, then this will be the 0.5 mm. So 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. So here, this one, the readings of the main scale is 5, 5.5. Okay, so the readings of the main scale is 5.5. mm, this is an mm. Just now vernier scale is in cm, but this one is an mm. Okay, and then the readings of the thimble scale, we read from here. This line is to see which line is coincide with this the straight line in the main scale. Okay, this 30, right? Okay, it coincides with this straight line in the main scale. So the reading will be 30, okay, 30. But 30 is not 30 mm, it's 0.30 mm. Each one represents 0.01 mm. So 30 means 0.30 mm. So with the reading of the main scale 5.5 and the readings of the thimble scale 0.3. So therefore the correct reading will be 5.5 plus 0.3. 5.5 plus 0.3, it becomes 5.8 mm. Okay, so that is how we take reading from this micrometer. Okay, can any of you tell me what's the main scale? What's the readings of the main scale for this one, the first case? What's the reading of the main scale? Jeannie, Liu? Yes, come on. Five mm, right? Mm, 5 mm. So 5 mm. How about the thimble scale? What about the thimble scale? Yes, come on. Zero point 0.07. Okay. 5, 6, 7. 0.07, not 0.7, 0.07. Okay, so therefore the readings of this micrometer is 5.07 mm. Okay, how about this one? What's the reading of the main scale? Yes, come on. What's the readings of the main scale? 5.5, that's correct. 5.5 mm. The readings of the vernier scale is still 0.07. 0.07 mm. And therefore the reading is 5.57 mm. Okay. I show this example is because a lot of students they make mistake. They sometimes they do not see this line here. Okay. So straight away this is 5, right? So they give the main scale 5.0 and then the vernier scale 0.07. So then the reading 5.07. That's not correct. You must be careful on this the second scale here. 0.5.
Alright, you are welcome from that video. I believe you enjoyed that video and you understood that explanation very well. But just for emphasis sake, that's why I'm showing you this diagram. See this diagram? You see, we have a scale of 4 to 5. You see, between 4 and 5, at the upper part, we have about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, about 10 lines, which means each of those lines is 0.1 centimeter. So we have 4.1, 4.2. Now, when you look at the MS is showing the main scale. You look at the arrow is pointing to the MS. The MS is the first, when you see the MS pointed to 4.2 centimeter on this vernier scale. But when you, on this vernier caliper, but when you look at the vernier scale, inside the vernier scale VS, you discover that the POC is called the point of coincidence. And that point of coincidence is number 8 line inside the vernier scale. The vernier scale, if you count the line inside the vernier scale, you see that the number 8 is the one that coincides with the main scale. And we call it the point of coincidence. That's why I look at it as 8. Therefore, from this diagram, the main scale is 4.2, while the point of coincidence is 8 divided by 100, which is 0.08. Then why the reading will now be 4.2 plus 0.08, which equals to 4.28 centimeter on this vernier caliper. Now let's look at the micrometer screw gauge. If you look at the micrometer screw gauge, you discover that inside the micrometer screw gauge we have this is that of the vernier caliper. Let's look at the micrometer screw gauge. For the micrometer screw gauge, you discover that we have 0, 5, and so on like that. So there is the main scale, then we have the CS, we call it the thimble scale. We have the thimble scale, we have the CS, then we have the point of coincidence. Now if you look at the main scale, you discover that the line you see the line, that line is pointing at 7.5. You look at it, 5.5, 6.57, then 7.5. 7.5 is the last line or measurement you can see before the timbre scale begin. Now, if you now check the timbre scale, you discover that the line of coincidence, the point of coincidence of the timbre scale is at 15. So you now say that 15 also divided by 100, you give it 0.05. Then you now add the main scale with the reading of the timbre scale, which is going to be 7.65 millimeter. It's just for emphasis, that's why I'm just doing this explanation. So after this class, maybe next class, I'm going to give you maybe some of this chart that you can practice with, so that you can also study with yourself. Thank you for enjoying this class. Next class we'll move to the measurement of mass and measurement of weight. Thank you for enjoying. Please make sure you subscribe to this channel. Please, I know many people have been watching this video. I really appreciate you watching this video, but I will really appreciate more if you subscribe. If you subscribe to this channel and like the video. When you like the video and subscribe it will make this it will make us improve and to do better in our video next time. Thank you for watching. Bye.